This is a short video. I want to provide a quick overview describing transformations of functions. And it's very important to understand that these transformations describe all kinds of functions. So I'm going to use this radical function to kind of illustrate these ideas. But again, many different types of functions these ideas will apply. So a couple of keys. Everything inside the expression is described as horizontal. So in this case, it'll be stuff under the radical if it was inside the absolute value, inside the quantity that was squared for a quadratic, inside the logarithm. Then those are going to be described as horizontal. On the other hand, things that are outside, so this coefficient A, this constant K out here, those are going to be described as vertical. So inside is described as horizontal, outside described as vertical. So let's start with H and K. Those are usually pretty straightforward. So if H is greater than 0, so this value right here is positive, then the graph is going to shift right. Now let me point this out because this feels backwards to some students. If I plugged a 2 right here, this would say x minus 2. Notice if I plug a negative though, a negative here, minus a negative would become a positive, x plus 2. So x plus 2 would shift to the left, x minus 2 is going to shift to the right. But think about the number that you're actually plugging in. K is very straightforward. If K is positive, it's a vertical shift up. If it's negative, it shifts down, the same number, okay? Now, these get a little trickier. Let's talk about A and B. If A, first of all, is a negative value, remember it's outside, so we're going to use the word vertical. If it's a negative value, it causes a vertical reflection. Or I want you to picture our coordinate axes. It will flip that graph upside down or reflect it in the x-axis. Okay, inside, on the other hand, that B value, if it's negative, it will cause a horizontal reflection or a reflection in the y-axis. Just think about that. Inside the expression horizontal, outside the expression vertical. So if A, and I'm just using absolute value here because the negative causes the reflection. So if the absolute value of A is bigger than 1, the graph will be vertically stretched, is the way that we describe that. If it's in between 0 and 1, so like 1/2, 1/3, the graph will be vertically compressed, or we can also call that a vertical shrink. So again, outside, we use that word vertical. How about inside? Remember, inside, this horizontal kind of feels backwards with the sign. Well, the language here also is going to be a little backwards from what we just described. So if the absolute value of B is bigger than 1, the graph will be horizontally compressed or a horizontal shrink. You could also use those words. If it's in between 1/2, 1/3, 1/5, then the graph will be horizontally stretched. Okay, so I want you to think about those things. Think about a vertical stretch, horizontal shrink, how visually those are similar. And I'd encourage you to make note of these things if you need to. Let's go look at some quick examples. I would encourage you to even pause the video right now where you can see these. Try to describe these to yourself or even write them down, and then come back and watch and see how your answers compare to mine. Describe how each function has been transformed from its parent function. So for this first one, now we've got a negative sign out front. So a negative sign out front, so vertical reflection, right? Or reflected in the x-axis. It's just going to flip it upside down. We've got that 2 inside. Now what did we plug in? We actually plugged in a negative 2 to make this sign positive. So this is going to be left 2, and you could say 2 units or just left 2 is fine. And then outside we subtracted 7, so this will also be down 7. How about this one? Now we've got that negative inside, so remember that's going to be described as horizontal. So horizontal reflection or reflected in our y-axis. Just going to flip it over there to the left side. Now we've got a 1/2 in here, coefficient. Remember, it's backwards from out here. So inside is going to be horizontal, and our language is backwards. So the 1/2, this is going to be a horizontal stretch. Horizontal stretch is the way we're going to describe that. And then our k out here is positive, so this one's going to be up 3 units. How about this? Then we have an exponential function. So the 5 is just the base of our exponential. If I had another number out here, I could maybe do a stretch or something, but this is just the base. So this is really my expression if we want to think inside. So it's right 4 units. Notice the sign feels backwards, but it's right 4, and then this is outside, so that's up 9 units. See how quick we can do these once we have a fill for them? How about a log? We've got a negative out front, so that's the same as this, isn't it? So reflected in x-axis, it just flips it upside down. Now this is inside the expression, so that's going to be left 1, and outside the expression, that's going to be down 8. So I hope that helps. You know, you do some of this practice, you get a feel for these. You can apply them to all kinds of situations.